Algebra 2, we're on lesson 33, and we're going to be looking at complex fractions. We're actually going to start not on page 149 because it does talk just about rules of algebra and satisfying equations to set us up for this idea of complex fractions. What I want to do is I want to look at the actual complex fraction of 33.1, which is found on page 150. So you'll notice a complex fraction because you have a set of fractions here over another fraction here. So it's complex, meaning that there's more than one fraction being a fraction. So here's how we're going to start this problem. We're going to work on the top half, the numerator, and solve this, okay? So first of all, we have to have the denominators the same. And you'll notice that there's an xy here, but there's only a y here. So in order to make these two denominators the same, we need to multiply this bottom by an x to make them equal. And what we do to the denominator, we do to the numerator. So now we can multiply that out. So x times x is x squared. We just solved this part of it, okay? Plus 4. And then our common denominator stays the same. So it's just over x, y, or you could put it yx. It doesn't matter. I like to do it in alphabetical order, okay? And it's not, we're not adding both of these together, so it's not like x squared y squared or xy plus xy. It's just the common denominator. Okay, now that is all over, okay, a over y. Now that the top is solved, now we're going to get this ay out of the denominator. And how we do that is just simply multiply by the reciprocal, so it cancels out and we're left with 1 on the denominator. And we're going to take this fraction, our reciprocal, and multiply up here, okay? So y times a. So now we're going to make this hopefully look a little bit easier by canceling out, okay? So notice this y and this y can cancel out. So we're left with on top the same thing, x squared plus 4. And then down here, the x times a is xa or ax. So this is our final answer, x squared plus 4 over xa. All right, let's look at one more. And this one is 33.2. It's a little more complicated, but exact same idea. So we have a over x plus y plus m over y all over x over a plus m. All right, this one's a little bit more complicated because you see something here. And what we're going to have to do is we're going to, again, find a common denominator. So you notice that we have a y, x plus y, and so we need to multiply by this y, okay? So we're going to multiply this section, a and x over y, by the y, okay, on both top and bottom, because the y is already here, but we also, because this only has y, we need to multiply this by x plus y. These two terms, okay, should have done this in red, these two terms are not the same. All right, so because this term and this term isn't the same, we have to multiply it by the opposite, so x plus y. Now, when we do that, we're going to be able to cancel some things out, and you're going to see what that turns into, okay? So when we multiply y plus a, we're going to multiply these two terms. We get ya plus, now we're going to multiply these two terms. So it's distributing. M times x is mx, m times y is plus my. So I just did the tops here. Okay. Now the bottom, or the denominator, stays the same. So I can say y times x plus y all over x over a plus m. Now again, we're going to do the same thing. We're going to multiply a plus m on top over x. Those all cancel out, but we bring this one to the numerator, and we're going to say a plus m over x. Okay, so a couple things. The x will cancel out here, which is great, but I also think that you have to be careful. Instead of doing that, let me back up here just a second. Let's multiply it all the way out so we can see what happens. Okay, so essentially we can leave this because we're multiplying this. It's kind of hard to multiply a plus m in all these terms. So let's work on the top, okay, to combine it. So we would say ya plus mx plus my times a plus m over, now what's on the bottom here, okay, we have this x, right? So we're going to say this x and this y times x plus y. And that's our answer. Okay, so you're going to see this kind of problem on number 16 in your textbook. And again, I don't think it's, or excuse me, not 16. You're going to see this 6 and 7. So let's do number 6. Okay, so we have m over p plus 3 over mp all over y to the p. Okay, so we're going to multiply the top by mp here, mp here, p here, and p here. So we have the top's going to equal, this first one is m squared p plus 3p, and that's this one. Downstairs, it's easy. We just have p oh wait, it's xp. I just realized I did this wrong. Let's do it again. M over p plus 3 over xp over y and p. Okay, makes more sense. So we have xp here, xp here, we have p over here, which equals x squared xpm right here plus 3p right here, and then we have xp to the p on the bottom, and then we're going to multiply the y over p, or p, excuse me, over y. So multiply p over y, and we can cancel out one of the p's. So we're left with xpm plus 3p over xp times y on the bottom. Okay, so that's how you do those problems. Hopefully that helps. All right, ask me if you have any questions.